What we have here is the traditional Saginaw 708 steering gear. They built these from about 1960 up until mid 90s or so, maybe late 90s. You can find them on GM cars, you can find them on Dodge trucks from 72 to 93 or maybe 98, I can't remember. But anyway, what we're going to concentrate on today is the rebuild of one of these boxes. These boxes' main problem is the sector shaft bearing area. The casting actually stretches out of shape and it makes them feel like they're tight on the bench, but when you put them back on the truck you can start seeing that shaft wig-wag side to side, and it makes for a rather unpleasant steering feel. We've developed a new solution to fixing that problem. First thing we have to do though is obviously get the steering gear out of the truck. It's relatively easy to do. You need a tool like this to pull your pitman arm off. Relatively basic. You need an inch and 5/16 socket to remove the nut. If your truck's four-wheel drive, you can't get the socket on it before you get the box off. So you have to take the box off the truck with the pitman arm and then remove the pitman arm. The one tool that everyone needs to have before they start any job is you need a copy of the factory service manual, the one that Chrysler built, or the one that General Motors wrote. Either one is fine. First thing we got to do is disassemble the nasty dirty box. When you take your lines off here, a lot of times they're going to break because the line rusts to the fitting. And then they twist around and they shear off, and oh well, that's the way it goes. They're cheap. Anyway, get them off there. Unbolt the 4 bolts or the 8 bolts if you've got a four-wheel drive. Take off your pitman arm. Obviously take off your steering shaft. And then once you get the thing apart and get it on the bench, the first thing I like to do is I like to take the sector shaft out of the unit. You can remove these 4 9/16 bolts, or excuse me, they're 3/8 bolts, but they got a 9/16 head on them. Then, in order to get that gear get that shaft and gear out of the box, the box has to be centered. So what I'll oftentimes use is a very small pair of vice grips like these. If I have to move this, you can also use an old yoke. If you happen to have an old yoke around. When you put these on there, don't get medieval with them and clamp the hell out of them, because if you do, you're going to tear up the splines on there. So you don't need a hell of a lot of force. All you need to do is just have them just barely click on there like that. That's all you need. Then you can take a soft-faced hammer like this. And kind of tap it out of there, and then you can twist the cap around and you can look. Okay, that gear is not centered, so what we're going to do is we're going to center that gear as we make a mess. Alright, now that gear is centered, now we can tap it the rest of the way out. You see how that gear is right there? If you notice it, this one tooth is larger than these other two. This is what you call a variable ratio. So it has one ratio in the center, and then it has a different ratio off to the sides. I could spend hours explaining gear ratios and gear teeth grinds and that kind of thing, but there's basically 2 types. There's the variable ratio like this, and then there's the one that has the 3 teeth that look pretty much the same, and that's a much lower gear ratio. You'll find most of those back in the 70s on pickup trucks and things like that. Later on, Saginaw division went to this variable ratio because it made for a better handling vehicle, and you didn't have to have quite so many turns lock to lock. Anyway, we're just going to set that off to the side for the moment. Now that we've got our gear here, like this. Alright, this nut right here, this is called the spool valve right here. That's what actuates the hydraulics pressure to be pushed on one side or pushed on the other side of the piston to relieve your effort. because of the rotation of the wheels, it blows all the dirt and gunk all over this tin can nut, and it has a tendency to get rather rusty. I have a round-nosed chisel here, and sometimes I'll hit them like that to get them loose. If they don't come loose, put it on the back edge like this, and then rotate it and hit it. Now this is a wheel bearing socket. This particular one is one that I made here in the machine shop. The nut measures 2 3/4 inches, and this socket is probably 20 or 30 thousandths larger. It fits Dodge and Chevrolet truck front wheel bearing nuts. Anyway, you can stick this socket over it like that. Take my impact wrench and we'll just pound it off. This one chose not to come loose for whatever reason. We'll probably have to get medieval with it. Usually what happens is the nut comes off and leaves behind this valve. Anyway, once you get that nut off, even though this one's stuck, you'll notice that there's 2 holes. Let's see, where's my pick? There's 2 holes right here in it. And sometimes they get rust and junk in them, so take your seal pick and kind of dig the junk out of them. Okay, what you can do, if you don't have that, this is the tool, the spanner wrench that you would normally use. This one's just a Williams adjustable spanner wrench. There's nothing particularly special about it. You can buy them any industrial supply. And this particular one has 1.75 pins in it. So it's not that complicated. What you do with this spanner wrench is you hold, it goes down in those 2 holes like that, and then that is what pulls that thing out. This nut is just rusted on there real bad right now, so we'll worry about getting that nut off here shortly. For right now, how we take this apart, there's a snap. This is the what we call the spool valve seal, or the worm shaft seal, or whatever you want to call it. Input shaft seal, doesn't really much matter. You dig all the gook out of there. And I'll blow it off so you all can see it a little bit better. And I got a pair of snap ring pliers there, wiping all the gook off it. If you look real close, you can see a snap ring there. So you clean the holes out good with your seal pick, and then you put those pins down in there nice and tight. It can be a little challenging at times. Get the tool in there, and I'll put my thumb on it, and I squeeze it in there, and then I take the snap ring out like that. Notice the size of this pair of snap rings. This particular pair was made by a tool company called KD, and the model of the tool is 3491. You can get KD tools almost anywhere. There's 100 other manufacturers. I think there's one manufacturer that makes all this style of snap ring thing. But the big thing is, as you notice when I stick the pins in here, you'll notice that my snap ring plier pins fit the holes well. If you try and use a pair of snap ring pliers that's too small, they don't get a good grip in the holes, and it can be very, very angering and aggravating trying to get snap rings out. Anyway, once we got the snap ring out, now we're going to see if we can get this spool valve out of here. Just pull that end off. and then there's seals in here. And let's see, just to hold it tight, I'll probably stick that thing back in there for a minute. Doesn't matter. You don't want to clamp anything to the sides of this thread. You'll bugger the threads up. Anyway, then you just pull the seals out. You'll notice that we have one normal seal here, then we have this other one that's not much of anything, and what this seal is, it's kind of a dust seal. It just keeps, it's supposed to keep the dirt from getting down, trapped down in and around the rest of the seal here. So anyway, now we've pulled those out, we can throw them in the garbage can. Alright, so now you take that off and just set it off to the side there. Now here's our reaction valve, spool valve, whatever you want to call it. And you're looking on the edge of it here to see if they're looking on the surface there. I don't see anything particularly wrong with this. So we'll just kind of wiggle it this way, wiggle it that way, and then it comes out the back. Doors entered or anything. We'll do parts inspection later. Anyway, we got it all apart here. I don't see anything particularly bad about it yet. Alright, moving on with the disassembly. Here's a part that can be somewhat annoying. This is just an aluminum plug that is jammed into the end of this thing. There's a metal snap ring holding it in that looks just exactly like this. If you look on the side of the steering gear, on this edge right here, just kind of scrape your thing around, and then eventually you're going to come up with a hole. See the hole right there? Okay, what that hole is for, so you can take a punch. You can stick that punch in there, and it's going to hit that snap ring and try and move it away. So you can get your seal pick underneath the snap ring and get it out. Okay, if you see how it moved that snap ring down, boy, is that thing tight. You might want to take and snap that a little bit. You can see this one's going to be a real joy. You don't really need to worry about tearing up the snap ring. If you tear up the snap ring, there's a new one you're going to get in the kit. I know you can't really see well what I'm doing here, but you'll get the idea of when you start doing it. Oh my goodness. Okay, I'm barely getting my pick underneath there. Now I'm going to try and take this other punch and stick it underneath there. And as you can see there, it's starting to peel out. You have to fight this thing every inch of the way. 40 years of salt and rust and garbage underneath there doesn't help any. Sometimes you can just grab it with a pair of pliers. Again, don't worry about getting medieval on it, because you get a new one. Anyway, boy, isn't this one just going to annoy me to death. You got a press. You can also stick them in the press and press that piston down. It'll come out a lot easier that way. Maybe we'll go ahead and do that. We'll move some of the precision measuring tools here off of the press. And if you don't have a press, you can, if it gives you too much trouble, just rip it out of there. But if you have a press and you really don't feel like being annoyed, just put the press in there and well, that press isn't helping as much, is it? Well, you know, things are pretty old now. Got it. When they get rust, when they get a lot of rust in there, it causes the aluminum to swell, and they just really force themselves in there. Well, we're not going to worry about that snap ring. It's done. All right, let's take it back over on the bench and see how much more medieval we got to get with this thing to get it apart. Alright, one thing I should have mentioned but didn't already was after you remove that, the worm shaft comes out. That's your worm shaft. There's a bearing and there's two washers on here. These washers are called reaction springs, and just think of them when you hold the thing like this and you put it back together. Those washers, aka reaction springs, they always go on like it was a dinner plate upside down. If you put these reaction springs on the wrong way, your unit will not work. But we'll talk about that more after we get closer to that moment. Now that the worm shaft is out, we got to be very careful that we don't lose our 24 ball bearings. The ball bearings sometimes are silver and black. If they are silver and black, you put it, when it goes back together, it goes back silver, silver, black, silver, black, silver, black. The black balls are actually a little bit smaller than the silver balls, and so it makes it, they're actually more like a spacer, and they don't really carry as much load. But anyway, we're going to worry about getting the rest of it apart now. I got this long punch here. What we're going to do is we're going to tap on that piston, and it's going to push that piston all the way to the end, and it's going to spit oil all over the place. And I don't know about you, but I hate it when oil spits all over me. So this workbench that I have right here, you notice how it's got borders on it. It actually tilts to the back, and in that corner over there it's got a hole drilled in, and then it's got a piece of plumbing pipe and a coffee can. And so when all the oil runs out of things, it runs to the back of the bench and over that way, and it runs into that coffee can. I made this out of an old pair of legs and just some plywood, and I put some urethane over top of the plywood. But that's all I use it for, is tearing down steering gears, transmissions, etc. Things that are going to leak oil and make a mess on everything. Okay. I gently tapped on that thing, and there is that nasty plug. It's nice and corroded. We'll just throw it over to the parts pile. Next, we're going to remove our piston. There's our piston. Okay, now that I got my 3/8 socket, this is the ball guide right here. And that's what the ball bearings circulate through. So we'll come I'll explain more about that when we go to reassemble the unit. So let's put, there's a little cup, and I'm going to take all the ball bearings are now laying down on the bottom of this case. You don't want to lose these ball bearings, because these are not ball bearings you can buy down at the local hardware store. These bearings are select fit, and they come sized in tenths of a thousandth of an inch. So you always want to be sure that you don't lose any of them. Should have 24 of these bearings is what they specify. And it looks to me like this particular unit does in fact have the black and silver balls. Sometimes they do and sometimes they don't. What we're worried about today is I'm going to wipe off the ball bearings so everybody can stare at the ball bearings. I mean, after all, it's not who you are that's important, but how you hold your ball bearings that really makes that who you are in life. As you see, some of those bearings are black and some of them are silver. Like I said, the black ones are smaller than the silver ones. Your Chrysler factory shop manual actually will be a world of information for you, and you always want to refer to your factory Chrysler shop manual whenever you're doing anything. What I do is and believe it or not, after all these years, I even still read those manuals. The Bisco Books makes the Dodge manual on CD. What's nice about that, you load it on your laptop and then you go to the pages that you want, and then you can print them off, bring them out to the shop, kind of like this right here. And then you can get them all greasy and nasty, and you're not hating life because you didn't ruin your $150 shop manual. Anyway, moving on. All right, the worm nut here is pretty well gutted. We didn't have to take this out for disassembly, but we will need it out for reassembly, and we will need it out for cleaning. So we're going to take this plug out of the end. There's nothing to it, it's just a hollow plug. These steering gears really are not that complicated, and they're really not that difficult to rebuild or service. You just have to know what little things to look for. The biggest problem in these, like I said before, was the castings that stretch out. Alright, now we're going to go back to that area. They stretch out in this area right here, and they go kind of like this. The bore will kind of go like this. So first thing we got to do is we got to get out our pair of handy dandy KD snap ring pliers and our seal pick, and I'm going to kind of dig out the junk out of the snap ring hole so I can get it out. Sometimes I think snap rings were some kind of evil conspiracy to make the world crazy, because they can be a real pain to get out. All right, now we've got the snap ring out. We're going to take our big drift, and that one just pries right out. You notice I got a washer. There's a washer underneath that snap ring. Then if it doesn't want to be cooperative, you just flip it over like this. You grab an edge of that seal. Put a little side there on it, catch it, and then just knock it out. And this one's nice and rusted in. Okay, you can cut for a minute. Now the older Saginaw steering gear boxes actually had 2 seals and 2 washers in them. Later on, they figured out that they could use only 1 seal and get away with it. And you know how they are in Detroit, why do it right when you can do it cheap? Anyway, the later ones only have 1 seal in them. So depending on what box you have, this particular box is out of a 1991 and a half D350 Dodge 2-wheel drive truck with Cummins diesel engine. They're one of the worst offenders on these because there's so much, that engine is so heavy, and when it's sitting right over that axle, and it really stretches the housings out bad. So it's one of the worst offenders, no question about it. And I'm digging for the second seal now is what I'm doing. Trying to get the second one out. Four of these in there. Here's another tool. You can get these down at Sears and Roebuck. I think probably KD makes them too. And I kind of, for a stubborn seal, I kind of like them. You can put one opposing each other, kind of like that. And then you can pray. My goodness. Alright, we're going to go back to trying to beat it out with the drift. Between all of that, it comes out. Anyway, we'll show you what the seals look like better when we're putting them back in, but here are the 2 seals that I got medieval on and pulled out. You want to try and hit the seal when you're in there. You want to try and hit the seal in there and not so much up here, because you really don't want to gouge the housing when you're coming out. So we'll deposit those in the garbage can where they belong. Now the big offender. Now the big offender. We're going to first knock this bearing out of its housing. Because what we're going to do is we're going to remachine that housing, put a bushing in it, and roller burnish that bushing. Which roller burnisher expands it so it's nice and tight. Now, let's see if I'm my bushing driver. Alright, here we're going to knock the bushing out. Or not the bushing, the bearing out. This is just a tool that I made on the lathe. It's nothing really special. It's just an old junk, concrete anchor bolt, and I just took a piece of steel that threaded on the end of it and turned it on the lathe to fit the bearing. Anyway, we're going to knock that bearing out now. And if your box is one of the later model boxes, the bearing has a ridge on the end of it. So if that be the case, then you have to knock it out the other direction. And we'll do that now. This is one of the later ones. Okay, bearing is out. You're better off using some kind of bushing driver when you knock these bearings in and out, because if you don't, if you use a drift on them, you're going to definitely wreck the bearing. It really doesn't matter because we're not going to reuse the bearing again, but it's easier if you have the driver. What I'm going to do is I'm going to offer the housings that are with the new bushing in them and a new bearing in them. So you really don't even have to bother taking that out. I can take it out if you're going to have me do it, or if you're going to have another machinist do it, they can do it. It's not that big a deal. If you look very closely at this bearing, you will notice, one, it has a ridge on the top of it, and that's to keep the bearing from pushing its way up out of the case. Frankly, I never had a problem with them moving. And if you'll notice, there's a cage in there, and you'll notice that there's a big space between each of the needles. Are we able to see that pretty well? So if you go back into the 60s and 70s, this was the bearing that was used in them. You'll notice it has no ridge on it. You'll also notice when you look inside it that there's no cage in there, that it is a full complement of needles. And that's called a full complement drawn cup needle bearing is what that's called. A company called Torrington was the original company that manufactured these, or actually invented them, I believe. It's a stainless steel cage which the needles roll in. The problem here is when you press a new bearing in, a worn housing, the housing, let's say, will have clearance here and here, but it'll be tight here. The cage is nice and tight, so you drive it down in there and it's tight. But then when you put the sector shaft in behind it, and it's sitting on the bench, it's pretty tight. It'll be in there pretty tight. But as soon as you start putting load on it with the arm, it'll start deflecting into that area on either side, causing that shaft to wigwag like this. And it doesn't take very much motion at all at this bearing to add up to a whole lot of motion up there in your steering wheel. So this bearing, I try and keep the fit on this. I try and keep the fit on this as close to zero as I possibly can when I machine them. When we remachine the housing and put the bushing in it, we have to have this hole exactly the right size, because as this bearing is put in there, it's crushing that bearing. And if we don't have enough crush on that bearing, the shaft will not fit tight inside that bearing. We're going to take a break for a second because we're going to wash up this casting, this nasty dirty casting. We're going to get ready for the boring process. Now we're come to the part of the adventure where we remount the housing and straighten out the mess. This is a jig that I made for holding the steering gear. And we're going to bolt our jig bottom of it. Okay, now we've got our handy little jig on here. I'll set the boring machine to the right height. Okay, there we go. We got our humongous reamer. And we got relatively centered. Now what we're going to do is we're going to bore out that egg-shaped housing. Okay, now that we've gotten the housing bored out, now we're going to check what size it is. This is called an intra-mic. It's for miking the inside diameter of holes. You don't see these too much out in the automotive world. They're rather expensive. But we like to do tight work here, so we're going to use our intra-mic. Okay, this is a 1 11/16 reamer that we just ran down through it. So what we need to do is we need to make a bushing, and we made it on the lathe. And we got a little shoulder up here to tell us when to stop driving it in. So we're going to drive this bushing in. Then we're going to use what's called a roller burnisher, which is then going to expand the bushing much like a rolling pin would roll dough out. So instead of reaming it out, we're going to be rolling it out so we get the exact fit, so when our bearing presses down into it, we then in fact have a tight product. This is what's called a roller burnisher. It's got a micrometer top on it. As you can see, it goes like this. These are like rollers out of your front wheel bearings of your car, kind of. This pin is tapered, so when it goes into the hole, as the tapered pin slowly goes down in it, these rollers come out and they roll that bushing out in its hole. So the first thing Alright, our bushing is nicely turned down in there. We're in there good now. So now we'll pull it down so we release the rollers. Get stuck in there. And we'll turn the machine on one time. The roller burnisher that you're seeing here now, I've already got it set to the exact right diameter, so we don't have to mess with it. But when we're first doing this, we'd have to run it up and down there and keep adjusting this till we get the right amount of crush on our bearing. I'm going to take my intra-mic, stick it down in there again. We're looking for 1.625 is our maximum, but what we really want is 1.621. Alright, as you can see now, that shaft, it didn't just fall in the hole. In fact, you can see now that I got it in the hole, I'm not getting it back out of the hole. So, let me see if I can tap it. As you can see, there is absolutely no movement whatsoever in that shaft. None whatsoever. And what we did was we burnished it with the roller burnisher. We just kept burnishing it. And when the shaft wouldn't go through the first time, I measured it with my intra-mic. This wonderful little tool here that probably costs more than my house. But so I opened it up 1/2 of 1,000, and then the shaft goes in, but it's a hard push. And that's what we want, because once this thing gets on the road and you have that arm on there jerking around, it's going to loosen it up. Now if I find my mallet, I'll knock the thing back loose and look at it twice. Here's the mallet. And remember what I told you, you have to have that gear in the center or it's not going to come through the hole. There we go, just so I can see how my hand is knocking it. I can't hardly pull that, but I can just barely thump it out. And that's about how tight you really want them to be if you want the truck to go down the road, or the car for that matter, not be all over the road. So we've bored it, we've put a bushing in it, we've roller burnished the bushing to exact tolerances, and we've test fit the sector shaft that's going in the hole, because you know these are mass produced parts. So between where and what day they were made, there might be, you know, a thou or two difference in tolerance. So if I'm looking for, you know, if I'm looking for tight tolerance, I need to have the shaft that's actually going to go in this box, and every one of them is going to be hand fitted differently. So as you can see, you can put it in here. Let's put it in the other way just for demonstration purposes. Yeah, so you can, it's a hard push, pushing it in there. You see that? Now you see, there's absolutely no movement in that whatsoever. Absolutely none. And that'll be the tightest steering gear box that whatever vehicle goes in probably ever had. Because they just don't take the kind of time and effort to do these at the factory like I just did here today. Anyway, this concludes the chapter. We're going to have another chapter on how to rebuild the box, how to put it back together. It sounds hard, it sounds complicated, but it's not. This is really the hardest part. This is something that's, it helps if you've done them over and over again, or if you're, you know, if you're a machinist or an engineer and you're used to doing touchy-feely work like this. This is the hard part. Anyway, stay tuned for the reassembly saga.